Hello, my name is Angel. Welcome to my King Air B200 power plant presentation. It's on the Pratt& Whitney PT6A-42 engine propeller system. The system is the PT6A-42 is a reverse flow free turbine turboprop engine. It has two sections. One's a gas generator, and the second is the power turbine section. It actually produces the thrust. The four-blade constant speed propeller is controlled by primary, overspeed, and fuel topping governors. For redundancy, the system ensures reliable thrust and performance across all flight envelopes. Here I have a diagram of one. In normal conditions, the max takeoff power per engine is going to be 850 horsepower, static horsepower. The gas generator normal limit is going to be 101.5%. This is about 38. This is achieved at 38,100 RPMs. And then the propeller RPM is a 1900 to 2000 for takeoff and max continuous RPMs. And the intake temperature limits are going to be 800 degrees Celsius for takeoff and max continuous operation. Then oil temperature is going to be from 10 degrees to 99 Celsius for the normal operating range from cold to hot. And the oil pressure is going to be between 90 and 135 during normal operations. It does have two alternate modes, as engine auto ignition, which arms the ignition system to fire automatically if the torque being produced drops below a specific threshold. This crucial feature prevents engine flame out in heavy ice conditions or severe turbulence. And also has an anti-ice mode, which deploys inertial separators to alter the flow of the intake. This prevents ice and moisture ingestion to the engine core, also preventing gravel from improved airstrips. There causes a slight drop in torque, and this drop in torque is met with a rise in intake temperature. For the cockpit indications, there's instruments that provide intake temperature, torque, prop RPM, the RPM of the gas generator, fuel flow, and oil pressure and temp. And it has an annunciator panel which alerts the crew to specific faults, including left or right engine fire, left or right oil pressure, and left or right chip detection. There's about four malfunctions that can be had. There's a compressor stall, which is indicated by loud bang or popping noise, sudden fluctuations in intake temperature and torque, and possible visible flames from the exhaust in severe cases of this. Then there's a hot start, which is when the intake temperature rises rapidly towards or exceeds the starting limit, which is 1000 degrees Celsius during engine start, and requires immediate fuel cutoff and shutdown. Then the prop governor could also fail. This results in unrecommended RPM changes in an overspeed event. The overspeed governor will intervene and limit propeller to 2120 RPM. That's why there's redundancy. Then there's engine flame out. This is what's usually seen in movies when the jet engine goes out and shoots out a flame, marked by sudden loss in torque, a rapid drop and intake temperature, a distinct yawing motion towards the dead engine, and left or right oil pressure warnings. This would affect the electrical system, as loss of one engine also results in the loss of its generator creating power. The crew must monitor remaining generator load and initiate load shedding if the limits of the remaining generator are exceeded. There's environmental system, as the loss of bleed air from the inoperative engine could stop cabin pressurization and heat independently, and it relies on the remaining motor for those. Same with the de-icing boots, rudder booster, and flight instruments. They all rely on engine vacuum. So any of them that rely on that may experience reduced capacity or may need to be isolated upon engine failure. There's a bunch of considerations pilots have to take into effect when this happens. The number one is they have to counteract the asymmetric dust made by the dead engine with rudder input to keep the plane going straight. They have to feather the dead engine's propeller to minimize the drag created by it. Some planes are auto feather, some are manual. Then they have to assess if the plane could be restarted and if restarting the plane would be a safe and viable idea, making sure there's no fire or some crazy failure that would cause more danger to the crew. And then they have to adjust their altitude to the single engine service ceiling, as that could go down, and recalculate fuel burn and range requirements based on the remaining motor. Overall, the PT6A-42 engine propeller system form the reliable core of the King Air B200. Knowing its normal limits, alternate modes, and cascading failure effects is absolutely critical for safe multi-engine operations. My references are going to be the Operating Handbook 2014 printed version from the Beechcraft Corporation, the FAA Airplane Flying Handbook from the U.S. Department of Transportation, and PT6A Engine Operating Manual from Pratt & Whitney itself. And that is it.